Hi, this is Mrs. Secorn. If you could find this page in your notebook, we're going to take, I think, 3 pages of notes today and finish our notebook. The Pythagorean theorem. We've been studying that. But what I'd like for you to do now is label the shorter leg of each right triangle A, the longer leg B, and the hypotenuse C. Okay, so short leg A, long leg B, and the hypotenuse C. Remember, it's across from the right angle. Short leg, long leg, hypotenuse. Short leg, long leg, hypotenuse. Okay, the next section is tell whether the triangle is right or not. If it is right, the formula a squared plus b squared should equal c squared. Okay, so this is probably the c, right? So 20 squared is 400. And the sum of 6 squared plus 12 squared, let's find that sum. 36 plus 144, that gives me 180. Are these two equal? No, that's 400, that's 180. So that is not a right triangle, even though it looks like one. The next one. Okay, this looks like the longest side. So 26 squared is 600 and I think 76. 24 squared plus 10 squared is 576 plus 100. This does sum to 676. So yes, these two numbers are the same, so it is a right triangle. And the next one. 10 squared is 100. 5 squared plus 5 squared is 25 plus 25, and that's 50. That does not equal 100, so this is not a right triangle. Next page. Okay, the Pythagorean theorem, we're still continuing with this, but we're going to put some real-world problems here. First of all, though, I want you to know what a perfect square is. So it says give 3 more examples other than 25 that's a perfect square. Well, 6 squared would be 36. Another one, 7 squared, 49. 8 squared, 64. We can continue like that. Let's write down some that are not perfect squares. Okay, so these are not perfect squares. Well, 40, 30, 10. You can't take the square root of that and get a whole number. All right, let's try these 3 problems. We're missing this leg. So our x squared will equal 15 squared minus 13 squared. 15 squared is 225. 13 squared is 169. And if we subtract that, I think we get 56. Okay? And the square root of 56 is about 7.5. The next problem, we want to find out how far the ladder is from the building. It's making a right angle, and the ladder's 18, and the height of the building is 15. We need to find x. Again, this is a leg, so we're going to subtract the hypotenuse, 18 squared, minus our 15 squared. X squared equals 324 minus 225, or x squared equals 99, or x is the square root of 99. You know the square root of 100 is 10, so it's probably about 10. If you put that in your calculator, I think you'll get 9.9. So the ladder is 9.9 feet from the wall. The next one, I think it wants you to find out, I can't remember how the word problem is. It's on our test, and it's on our practice test. How far is it from the fairground up here to the baseball field? Okay. Well, I don't see a right triangle. Well, we can draw one in. If we connect Wes's house to the baseball field, I think this was the baseball field, and this is the fairground, then we can see it's a right angle here, and this is the hypotenuse. Now, how long is this leg? 1, 2, 3, 4, 5. And the leg from Wes's house to the fairgrounds is 1, 2, 3, 4, 5 also. So x squared equals our two legs, 5 squared and 5 squared, or x squared equals 25 and 25. X squared is 50. So then the square root of that would give us x, and the square root of 50, well, I do know the square root of 49. That's about 7, so it's going to be a little over 7. So x equals, and I think if you put it in the calculator, you'll get 7.1. About that. Okay, the next page. Okay, I'm sorry that the stapled notebook is covering this side. We want to find the perimeter, the distance around this shape. This distance is 1, 2, 3, 4. Here's what got cut off. 1, 2, 3, 4, 5, 6. I'm sorry. And this is 7. 1, 2, 3, 4, 5, 6, 7. And this is 3. Okay, so right now we have 4 and 6, and 7 and 3. That's 10 and 10. That's 20. But we want to find this distance. I know it looks like it's 3, but it's not, because a diagonal is longer than the distance from vertical or horizontal, from dot to dot. We're going to drop in the sides because we're going to use Pythagorean theorem. We've got to find this distance here. So we'll draw in a line there and one here. You can see it's a right angle there. So this side's 3, 1, 2, 3, and so is this leg, 3. And our hypotenuse is x. So we'll say x squared equals 3 squared plus 3 squared, or x squared equals 9 plus 9, or x squared equals 18. So x is the square root of 18, or x is, I think that's about 4.2. Right? The square root of 16 would have been 4, so it's a little bit more than that. Okay, so our perimeter then is 4 plus 6, that's 10. 7 plus 3, that's 10, so it's 20 plus 4.2, this distance here. So our perimeter is 24.2. Okay, the next problem. This was on an OGT. They had a right triangle inside of the circle, and you can see that the hypotenuse is 5, and this part of the triangle is 3, is the short leg. We are trying to find the long leg here, which happens to be the radius. Okay, and it's a leg. So we can say r squared equals 5 squared minus 3 squared, right? Because we're missing the leg, which is 25 minus 9, which is 16. That's what r squared is. So then r is the square root of 16, or the radius is 4. The radius is 4. Now our problem says find the area of the circle. Area equals pi r squared. Alright, so we'll plug that in our formula. Area equals pi, and our radius is 4, and we want to square it. Pi times 4 squared. Okay, 4 squared, 16. 16 pi. Well, that's weird. They wanted the exact answer, okay? 16 pi. They didn't want you to take 3.14 and multiply it times 16 here. Okay, so be careful of that. If you did, you could multiply each one of these and see if you get the right answer. Okay, and the last problem of the notebook is this one here. We are to find the area of triangle ABC, like you did for homework last night. Okay, you can see there is a right angle here. How do I know this? Because this is isosceles. Dropping the height, then the altitude makes it perpendicular. Okay, so here's our right triangle. The 13 is the hypotenuse, and this leg is 12. I have to find this distance here. Okay, so x squared equals 13 squared minus 12 squared, which equals 169 minus 144, which equals 25. That's what x squared is. So x is the square root of 25, or x is 5. This is 5. Now let's find the area of the whole triangle ABC. Okay, the area formula is 1/2 BH, 0.5. Now my base, I'm talking about the large triangle, so if this is 5, this is also 5, so my base is 10, and my height is 12. 10 times 12 is 120, and half of 120 is 60. And this is in inches, and it's inches squared. Thank you.